Welcome to Summarize Science, where we dive into the most interesting technological advancements. Today, we are talking about a project called SpiderCam, a 3D camera that takes inspiration from the animal kingdom. Specifically, the researchers looked at jumping spiders, which use a unique method to estimate distance with brains the size of a poppy seed. They developed an ultra-low-power camera system that can see the world in 3D without draining a massive battery. The hardware setup for SpiderCam is quite ingenious, utilizing a beam splitter and two separate image sensors. This design allows the camera to capture two images of the same scene simultaneously, but with slightly different focus points. Just like the layered retinas in a spider's eye, these offset images provide the data needed to calculate how far away objects are. By using this approach, the system avoids the need for heavy lenses or moving parts. Processing this information in real time is usually very demanding for a small device. However, the team created a specialized algorithm that works efficiently on a low-power chip called an FPGA. They even accounted for the fact that cheaper, smaller sensors can be quite noisy and grainy. The algorithm is robust enough to clean up these errors while still calculating depth at a fast rate. The results of this on-device computation are impressive, as seen in these colorful depth maps. The system can handle continuous surfaces, sharp edges, and even transparent or reflective objects. It even captures accurate depth for moving objects, thanks to its snapshot-style capture method. This means the camera doesn't get confused by motion blur the way some other 3D systems might. One of the most groundbreaking aspects of SpiderCam is its power efficiency. The entire system, including the sensors and the processing chip, operates on just 624 milliwatts. To put that in perspective, that is less power than most typical LED light bulbs use. It is officially the first sub-watt total power measurement for a passive 3D camera of this type in scientific literature. When comparing SpiderCam to other existing technologies, the difference in power consumption is stark. Most other FPGA-based 3D cameras use between 2 and 5 watts just to function. By optimizing the math and the hardware, this team reduced power usage by 3 to 5 times compared to the current state-of-the-art. This makes the technology much more viable for devices that have very limited battery life. The researchers also performed various tests to see how different parts of their design affected the final image. They found that including factors like spatial variation and multi-scale processing significantly improved the accuracy. These tests confirm that even with very tight power constraints, the camera provides reliable data. It can accurately measure distances up to about half a meter away from the device. In summary, SpiderCam is a major step forward for efficient computer vision. It proves that we can create high-speed 3D sensors that don't need a backpack full of batteries to run. In the future, this technology could be integrated into smart glasses, tiny robots, or assistive devices for the visually impaired. The ability to see in 3D using almost no energy could change how small machines interact with the real world. Nature has always been a master of efficiency, and projects like SpiderCam show how much we can learn from it. Thanks for watching Summarize Science, and stay tuned for more amazing tech breakdowns.